Good morning, Abyssers. I need to make a direct apology to Gavin because I did not mention him yesterday, and he's somewhat tearful in the back of the class, so this is a public apology. Let me get my... Oh, I know where it is. Sometimes I organize myself and I'm just shocked. Alrighty. Elizabeth, you ready? Did I hand you notes? Okay. We're going to do this one. This is called an indefinite integral. You ready? Why is it an indefinite integral? Doesn't have the interval part. Doesn't have the A or the B. Correct? All right. So what we're going to do today is we're going to find a shortcut. It's going to be awesome. At least I'm going to think it's awesome. Okay. So can you give me, what does this do though, by the way, this indefinite integral that doesn't have an A or a B? Can you guys see that in the back okay? Hannah, is that better? Does it need to be bigger? Okay. Gavin, you can see it okay? Okay. So what's the antiderivative of? The purpose is to find the antiderivative. Is that correct? What is the antiderivative? Close. So we're 2 plus C. And so we call that capital F of X. Right? Okay. So over here, A and B are constants. And I'm going to write that here. A and B are constants. Like it could be 3 for A and 27 for B. Correct? Okay. So I'm going to have you put B in here and tell me what you would get. Perfect. And then I'm going to have you put A in here and tell me what you're going to get. Perfect. And then I'm going to have you take F of B minus F of A and tell me what you get. Ooh. So this would be B squared plus C, correct? I'll put in parentheses, minus, in parentheses, A squared plus C. Would you agree? And then I get B squared plus C minus A squared minus C. Would you agree with that? Because I got to distribute that minus sign. What is that? What's my final answer there? Right. B squared minus A squared. Perfect. Okay, Tyler, I know you've been gone. I'm just going to probe and see how much you know, okay? So this has an A and B, which is the interval. A is less than B always. And this asks you to figure out the what. Not in this case. No, this one does. Okay, so you're not sure about what this asks you? Okay, so we're going to go to Cameron. Okay? Cameron, what does this ask you to figure out? Correct. And the curve here is 2x. Okay, so and then what's the area underneath that between A and B? Okay? Now, this is how, at this moment, this is how we're going to figure it out. Okay, you ready, Cameron? What's the first thing I do? Now remember, A and B are constants, everybody, right? Got that? Okay. So what's the first thing I do? You want to find delta x. What is delta x? B minus A over n. Perfect. You want to keep going? What's C sub I? Can I write it like this? Yeah, you can I do it like that? Yeah. There's nothing wrong with the way you say it, but so what this is Tyler? That's the width of every rectangle. This is what we're going to input to get all our different heights for every rectangle. Okay? All right, you still on a roll, Cameron? Okay, the third thing is how I got the summation, right? Because I got to add up all the areas, right? And it's going to go I equals 1 to n. What's outside in front of here? B minus A over n. What's inside here?
It would be 2 parentheses A plus B minus A over n I.
Perfect. Perfect, perfect, perfect. Okay? So this gives me B minus A over n. And Cameron, I'm going to distribute this. Is that okay?
That's fine.
And I get 2A plus 2 parentheses B minus A over n times I. Would you agree with that?
Yes.
Hannah, still seeing it okay? Okay. And so now I'm going to separate this into how many summations?
2.
2, because I got a plus sign, I got one on the left and one on the right, correct? And so one summation will be this. Would you agree with that, Cameron?
Yeah.
Plus, the other summation will be this. I leave this I all by itself, correct?
Yes.
Alrighty, so what will I have in here? Well, on the bottom I have n here and I have n here, so what am I going to write here? And I'm multiplying, correct? I'm taking this times this, so what does that give me on the bottom? I got n times n. N squared. Up here, what am I going to have? I got b minus a times 2 times b minus a. In other words, I'm just taking b minus a times b minus a, right?
Well, it's 2b squared minus 4.
Yeah, we're not going to do that yet. That's like way too much work. Okay? And so I'm just going to write b minus a squared. Okay? You're right, but it's I don't have enough. You know how I am. I hardly have enough room the way it is. Okay? So this is b minus a over n times, now let's look at this right here. I have 2a that I'm adding n number of times. What will I get when I get rid of the summation? This is the hard part. It would be. It'd be exactly that. 2an. Can I write it over 1?
Yeah.
Plus, I got 2 times b minus a squared over n squared times, do you know what that is without looking in your notes?
Yeah.
Okay, now, Cameron, this part is completely selfish because I feel a strong need to do this. I'm bringing out my red because stuff is going to simplify. You ready, Cameron?
Yeah.
Bam, bam. Are you okay that I eliminated the ends? I watched Fargo last night, Cullen. 3rd season. These two brothers get into a fight. They got a stamp. Have you seen it? They got a stamp that's inside this picture frame with glass, and they're fighting back and forth. It's been kind of the whole focal point of the entire season. The guy grabs it and slams it against his face, breaking the glass. These are brothers. They're twin brothers. A piece of, my wife's watching this, by the way. Okay. And we're not supposed to watch violent films together because she does not enjoy it. How many of the young ladies are here are grossed out by me using the red pen? Good. Okay. My wife would have issues with it. Huh? How many guys? Okay. My wife would have issues with this. She'd be complaining and asking me to be fired. Okay. So anyway, so the guy's got a piece of glass stuck in his carotid. What's this artery called? Yeah, carotid artery. Okay. And the brother's going, no, 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 as he reaches out and he pulls it out. Oh yeah, that's where my wife got up and left. Okay. So anyway, I'm kind of in the mood now. All right. Okay. So Cameron, what happens to these twos? They're gone. Bam, bam. Okay. And this pool, right? This is only live. Okay. So now we're going to take a limit. So I got the limit, right? Because I'm adding to infinity. So anytime you add to infinity, you got to take the limit. And I'm going to take a limit of this. Are you okay that I write this as 2a times b minus a? I just put the 2a in the front of the b minus a, okay? And then this will be plus b minus a, the quantity squared, times n plus 1 over n. Does that look correct? I had to kind of move it because it got really bloody right there. Okay. Now, these are constants, correct? Like 3. It could be a 3. A complicated, Brady, a complicated form of 3. Okay? I'm thinking, when I get sad, Brady, I think of 3. In fact, I've gone so far as to write a big 3 on a piece of paper and just hold it when I'm sad. So when I go to funerals, sometimes I write a 3 down. Just hold it. Okay. I'm thinking about getting a stuffed 3. You know how some people have stuffed animals and they hug them? Okay. So anyway, this does not change. Okay? So as it goes to infinity, what will be the limit of this? The same thing? This is 3. Pretend this is 3 because it's scaring you. Wouldn't this be 3 as n goes to infinity? Because there's no n here, correct? So it's 2a times b minus a. Now here these have n's, but both these n's have a degree of 1, correct? And so this has got to be my leading coefficient over that leading coefficient, right? So what does that give me? Perfect. Okay. Now, I'll give you time to write that down. Now we're going to do a little algebra. Okay. We're going to distribute the 2a. What do I get?
2ab minus 2a squared.
Perfect. Plus, now, what do we get when we multiply that out in our head?
B squared minus
Oh, let's go slow. Go slow. Okay, you realize, in some sense, in some places like Perkins, I'm a senior citizen and have them for quite some time. Okay, b squared
minus 2ab plus a squared.
Would everybody agree? Aaron? Oh, comes the red pen. Bam, bam, dot, 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 dot. Right? Right, Carter? Back to Cameron. B squared. I got a negative 2a squared plus a squared.
You can take out one of the a, so it'd be just negative a squared.
You see this, Hannah? I'm going to back off a little bit for dramatic effect. Same answer. Okay? You see how long this is? See how short this is? So all I'm saying is a couple of things, Ellie. First of all, I got the same answer when I took the antiderivative, correct? the same answer when I took the antiderivative and plugged B into it and plugged A into it and subtracted them, correct? And more importantly, this, I can ignore the plus C, because what happens to the plus C? Bam, bam, they're gone, right? Every single time. I don't have to worry about that arbitrary constant when it's a definite integral. Page 2. So this is a big, big, big deal because we are tired of doing limits. It makes us sleepy at night. It makes us go to bed early. I know I have been. I went to bed at 11:30 last night, the earliest I've been in a long time, because I've been doing these limits in this class. So this is saying here, here's a function inside an integral. To figure out the area underneath this curve, you figure out the antiderivative. The number on top will always be b, the biggest number. You plug b into that function. Then you plug the smallest number, which is on the bottom. Do you notice how short people are always in the front of pictures? Why? Because the big people think they're on the bottom. The smaller number's on the bottom. We're going to plug A into that antiderivative, and then we're going to subtract them. And Allie, we don't worry about C, because C is going to be eliminated. Here's the first one. Ready, Gabby? Make this big again. So, Hannah, can you see that okay?
Yeah.
What is the antiderivative of x cubed?
1/4 x.
Now, watch how I show my work. Antiderivative. The next thing you're going to do is draw a vertical line. A is going to go on the bottom. Why? Because it's A. It's the smallest number. 1 is going to go on top. Time out. Hello? Yes, I do. Yes, I do. Kyle Conway, you need to go to activities after class. Not before class, not during class, after class. Yes, nice eye roll. It's about 7. Okay, everybody got that? Then what you're going to do is I'm going to put 1/4, and I'm going to raise something to the 4th power. And Gabby, back to you. What am I going to put in there? Gee whiz! Did you just call me? You know you're live right now? Yeah, you can watch yourself on YouTube. I'm live right now teaching. Every day almost. Yeah. You don't, Kyle, you don't need to go. And you can buy me a Diet Coke, she said.
I can.
Yep, bye.
Watch this.
Kyle, you see this hair? Okay. Back to Gabby. What goes in here, Gabby? A positive 1 minus 1/4. What goes in here? Negative 1. What do I get when I do that arithmetic? 0. Now, how is that possible? Well, I go to the machine. I turn it on. Ooh, I don't want that. I hit exit. I go up here. I delete. I'm going to come up here and write x to the 3rd power. 3. And I'm going to go to my window. And I'm going to go from negative 1 to 1. And I'm going to exit. I'm going to draw. And there's my graph. Now, actually, I'm going to change my window to make it a little bit nicer. No yawning. That's better. Do you see this under the graph? What this means, remember, this is a derivative. That means my function is decreasing to here. Turns around and increases. How far did it decrease? This amount. How far did it increase? This amount. It's like this. The people in the abyss can't see this, but there's a stool over here. Let's say I walked in this direction 3 steps, and then turned around and walked in the opposite direction 3 steps. Wouldn't I be back at the stool? That's my net distance, or my net area. So both of these are the same amount of area, except this is the opposite, and when you add them, you get 0. Does that make sense? Watch this. Shift, G solve. Calculus. Calculus again. -1, 1. And I get 0. Okay. Everybody, you're okay with figuring out your definite integral on your calculator? Okay. Next one, now I'm asking you to do the absolute value. And you could do the absolute value on your calculator. I will show you at a later time how to do that. But there are portions, like coming up on a quiz, where I ask you to do absolute value without a calculator. So if you look at this, all these y values from -1 to 0 are negative, aren't they? If I can't use absolute value, how do I make those y values positive? How do I make a -3 positive? Times it by a -1. So in other words, this graph looks like this. This graph is going to look like this. It's supposed to look the same. So I'm going to write this as the negative of a -1 to 0 of x cubed. Why is it -1 to 0? Because that's where the y values are negative. That's where I have to multiply by a -1. Plus, then I got to finish the integral from 0 to 1 of x cubed dx. So this gives me a -1/4 x cubed, wrong, to the 4th, sorry, from -1 to 0, plus 1/4 x to the 4th from 0 to 1. Which gives me a -1/4 0 to the 4th minus a -1/4 -1 to the 4th. That's this one right here. Plus 1/4 1 to the 4th minus 1/4 0 to the 4th. That's this one right here. Emma, A negative 1/4 times 0 to the 4th. What is that?
1 or 1 negative.
Let's try it again.
Yeah, it's negative 1.
What's 0 to the 4th?
Oh, yeah.
0. What's a negative 1 to the 4th?
Oh, a negative 1 to the 4th is 1.
What's a negative 1/4 times 1?
Negative 1 to
What is 0 minus a negative 1/4? 1/4. Perfect. Plus, what's 1 to the 4th power?
1.
Times a 4th. What is 0 to the 4th? Times 1/4. 1/4 minus 0. What's 1/4 plus 1/4? 1/2. This is my total area. This is my net area. Yes, ma'am.
Why did you break it up in two parts from -1 to 0?
Because from -1 to 0, this is where the y values generated by this curve are negative, and I want to make them positive, so I multiply by a -1.
Oh,
And they're already positive from 0 to 1. The only way I can make a negative number positive is multiplying it by a -1, and I know in this interval they're negative. Gabby?
So you only recommend doing this if it includes negative?
I only do this if I know the curve goes under the x-axis. And I can't use a calculator. If I can use a calculator, I will take the absolute value of that function. In other words, if I were to come to this, and I'd come up here, let me delete that. Oops, excuse me. I got to go to options, number, absolute value, x to the third, and everybody has a way on their calculator to get absolute value, and I can show you later how to do that. So now if I draw, you see how it's all positive? Okay, and so now if I integrate -1 to 1, I'll get a half. Okay, and so if I can use my calculator, I always use the absolute part, and I will show everybody how to do that on a TI and a Casio. Okay? Because you have that ability to do that. And I only do it if a portion of it goes underneath, and I want to know total area. Okay, Gabby? Total area. All right, so let's take a look at this. Aaron, antiderivative. Ampersand, yep.
So it'd be 1/3 x to the third minus x to so just 3x and plus
No, you don't have to worry about plus c, because plus c's are never with definite integrals anyway. So I got 1 to 2. So I'm going to have 1/3. What am I going to cube to begin with? 2 cubed minus 3 times 2 minus, right? Because there's my f of b, right, people? This is f of b right here. Minus 1/3 times
1
cubed minus 3 times 1. Okay? So 2 cubed. 8 over 3. Perfect. Minus 6 in parentheses. Minus. What's this going to be? 1/3. Minus 3. Perfect. Now, some people go and figure those out. I don't do it that way. I do it this way if I can't use a calculator. So this is Kruger doing it this way. I just find it a lot easier. Because then I take 8/3 and I take away 1/3. What does that give me? 7/3. A negative 6 plus 3. What? I don't think so. A negative 6 plus 3. Negative 3. So that's 7/3 minus 9/3, which is what? Negative 2/3. That means there is more underneath the x-axis than there is above the x-axis. I walked more to the left than I did to the right. I went down further than I went up. If I look at this, and I write x squared minus 3, I'm going to change my window to 1 to 2. Oops, not enough. There we go. So if you take a look at that, do you see how much area you have here that's underneath as opposed to that's above? Do you see how your answer is going to be negative than it is positive? Is that making sense? Over here, number 4. Josh, to be successful on this one, we have to get an exponent here. So I'm going to write this as the integral of 1 to 4. 3 what? X to what power? A what? It's a positive 1/2 because it's above the x. Above it's not in the denominator. I can't even speak. I'm sorry. Okay. So the first thing when I do this to figure out the antiderivative, I figure out what this exponent is going to be, and I write it as an improper fraction, 3/2. And the reason I do is I know I have to multiply the front by, beautiful. And what's still there that I haven't addressed yet that's hanging around? I just took this, right? I didn't talk about this, did I? So this is being multiplied by 3. Are you okay with that? Which is the same as 2x to the 3/2 power. I got to make this bigger for Hannah back there. Okay, Hannah? Yeah. Okay, and so this is going to go from 1 to 4, right, Josh? So I'm going to have 2, 4 to the 3/2 minus 2 times 1 to the 3/2. Minus. Okay, Josh, 1 to the 3/2. 2 times 1. 2. Okay, the half is like taking the square root. So what's the square root of 4? And this is like cubing. So what's 2 cubed? Times 2. Beautiful. And what's 16 minus 2? There's your area. Okay, Carter? You got the hardest one. When I got this when I was learning calculus, I spent an hour on this. Okay? I'm going to show you how not to do this. This is trig, correct? Right? So in my head I do this, because you should know these 3. Okay? 3 of them, by the way. Okay? Derivative of sine. Derivative of cosine. Okay, there are 3 primary trig functions. Sine, cosine, and the last one is? What's the derivative of tangent? Bingo. Now you don't have to do an hour. Okay? Down to seconds. What's the antiderivative of secant squared? Tangent of x. I mean, you should have saw the garbage I was writing. I am a former voodooist at the max. I was the lead voodooist in 1976 in Bemidji State. No one could do voodooism better than me. I'm a born-again mathematician. 0, pi over 4. The tangent of pi over 4, would you agree? Minus the tangent of 0, would you agree? I'm doing all the easy stuff because you're going to do the hard stuff. What's the tangent of pi over 4? No. Cosine is the square root of 2 over 2. In fact, sine is the square root of 2 over 2. In fact, sine and cosine are the same number at pi over 4. Thus, tangent is 1. What's the tangent of 0? Well, it's the sine of 0 over the cosine of 0, which is, and I would not give you undefined, 0. And I get, I'll do this. 1 minus 0, 1. Yes, ma'am. And I'm sorry, I got to make sure you guys see this. There you go. Okay, I'm answering your question. You didn't have one? You're doing yoga? That's what my wife does during math class. Has the bell rang yet? Next page. Oh yeah, I should have been called Norm. I would have been called Norm, but my older brother's middle name is Norman. Because Dad worked till the end of the day. And sometimes he went to overtime. Do you know how much an owner gets paid for overtime? Nothing. Okay. So I'm going to graph this. This is time. This is feet per minute. This is 1. This is 6. Are we okay with that? Abby, you're told that V of t is 5 feet per minute. What does that graph look like? I'll write it down even. V of t, it's already written there, but I'll write it this way. 5. What's that look like? Ah, what kind of line? Whoop, bell rings. We're done. You guys have a pleasant day. And Kyle, do not go to the activities office, but do buy me a